Here's lesson 4, more graphing linear functions. We will continue to keep on graphing these things and keep on manipulating the equations of these things. That's what this whole unit's going to be about. So let's first take a look here. We have to start to understand what these lines, how we can end up creating equations for these lines just by kind of looking at them. So let's kind of take an example here of line 1, the blue line. It's this one here going from this way, right? Let's try to give some labels to this line. One of the things we really want to notice is the fact that it's kind of going, as we look from left to right, this is going down. That means it's going to have a negative slope, and you might remember that from the scatter plot stuff with a negative correlation. It went from left to right. As it goes from left to right, it goes down. That's going to give us a negative slope. So when we look over here at our choices, the only one that has it, well, let's I guess look at the slopes. So we have 1/2, that's slope on that one. We have -3, so this one might work. That has a negative slope. And then we also have 2/3, that's a slope. So I think obviously here the only one that's going to work for line 1 is going to be this middle one. I'm going to go ahead and put it in the box here. I'm going to put 1 here. Now, the thing is that you really want to take a look at is how does the rest of this kind of shake out? Well, this tells me that the y-intercept is 4. That's what this piece tells me, right? So the y-intercept is 4. Could this be about 4 on the y-scale? It looks like it might be. All right? And so a -3 slope means really it has a slope of -3/1, which means I go up 3 and over 1. Let's start maybe around here. Go like up 1, 2, 3 over 1. Yeah, it's pretty close, right? Up 3 over 1. So it looks like that could be the equation of this line. Y equals -3x plus 4. Let's take a look at this equation here on the top. It says y equals 1/2 x plus 2. All right, so that means I'm going to rise 1 and run 2. And I'm going to have a y-intercept of +2. So let's see, line 2 or line 3. This one has a y-intercept right here, and this one has a y-intercept right here. They both look like they might kind of go up 1 over 2. That could be up 1 over 2. This one could look like up 1 over 2 or so. So they both look like they might have something similar in slope. So let's go by these y-intercepts. This one has a +2 for the y-intercept, and this one down here is going to have a -2 for the y-intercept. So it looks to me like line 2 here, it could pass through the point 0, 2. While line 3 here probably passes through the point 0, -2. So the intercepts here are 2 and -2. So that's going to tell me that the green line number 2 is going to be this one, and the red line number 3 is going to be this one. So we just kind of look at these equations and kind of pick apart the pieces, okay? The things to remember are the slope. So we have the form y equals mx plus b, where the m is the slope and the b is the y-intercept. Okay, so let's determine average rate of change. There's a couple ways to do this. Remember, the average rate of change is the same exact thing as the slope, okay? But there's going to be ways that we may want to be looking at the graph to determine this if we don't have an equation, right? So let's look here. We have, it says graph the function f of x equals 1/2 x minus 4. Now let's pick apart the key pieces here. The slope, so m, that is 1/2, 1 over 2. The y-intercept here looks like it is the point 0, -4, so the y-intercept is at -4. So when we go over here on our axis, let's go ahead and graph this. So let's start with the y-intercept. So I go over 0 and down 4. 1, 2, 3, 4. So this point right here is the y-intercept. Now how do I move from here? Remember, the slope is in the form rise over run. It is the change in y over the change in x. Okay, so I'm going to go up 1 and I'm going to run 2. Now from here I'm going to do the same thing, up 1, run 2, and again same thing, up 1, run 2. And now I'm going to use my line tool and create a line through those points. So let's see, it starts about here, goes through these points. I'll go ahead and extend this line like that. Put some arrows on the end. And now I have this line, the function f of x equals 1/2 x minus 4. So the next question here says name 2 points that this line passes through. Okay, how about we pick, let's use color green here. Why don't we pick this point and something else interesting, maybe this point. So what are these points? This one here is over -2, down 1, 2, 3, 4, 5. So 2, comma, -5. I'm sorry, -2, -5. And this one is going to be over 1, 2, 3, 4, and down 2. So this point is going to be 4, -2. So here's my 2 points. We're going to call it -2, comma, -5, and 4, comma, -2. And let's use these 2 points to calculate the average rate of change. Okay, so again, remember the average rate of change is the same thing as the slope. And the slope is just the change in the y's over the change in the x's. In other words, we call it y1 minus y2 over x1 minus x2. Now don't get all confused about this. Okay, let's go up to the top here and label these points. Let's call this point point 1. Well, if this point is point 1, then that's my first x, and this is my first y. And if this point here is my second point, then let's call this one x2 and this one y2. So now all I need to do is take and substitute these values into this formula, the change in y's over the change in x's. Okay, so if I start with y1 is -5. And I need to subtract y2, and y2 is -2. And that's all going to be over x1. The x1 here looks like it's -2. And the x2 here looks like it is 4. Okay, so cleaning this up a little bit, it's going to tell me -5 minus a -2. So let's add the opposite. So we have -5 plus 2, which is going to give me -3. And we have -2 minus 4. So that's like -2 plus a -4. That's -6. And -3 over -6, well, anytime you divide a negative by a negative, it becomes positive. And 3/6 is the same thing as 1/2. So we actually have positive 1/2. But we knew that this is what we were going to get. We knew we should get 1/2 because way up here in the original function, we knew that that represented the slope. It was 1/2. So what does this actually mean? It means that we move up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. And it stays constant like that throughout the entire line. All right, everyone's favorite, these statement reason proofs now. Okay, so sometimes the problem is we get these equations in a way that they're not set up in a y equals mx plus b form. Okay, so our goal here is going to be to take what's given to us and try and get it into that that y equals mx plus b form. Okay, that's called the slope intercept form. Right, because we have the slope and we have the intercept. Okay, so let's do this. So the first thing we want to realize is what we're trying to do is get y by itself. Okay, and remember when we were using the different skills for solving equations, we would always look at PEMDAS and go backwards through it. So the first thing I notice here is that we have addition, that I'm going to want to undo this addition. And the way I undo addition is by using the additive inverse, right? I would use subtraction. Well, the additive inverse of 3x would be negative 3x. So here I'm going to have 2y. I still have this plus 3x. And now I'm going to subtract 3x. Remember, whatever I do to one side, I do to the other. Okay, and what I'm doing here is the additive inverse. Okay, that's the reason. Remember, the statement is the math part, the reason is the words, okay? The next thing I would do is I can write this out now and just say, well, let's see, 2y plus 3x. This 3x minus 3x is going to be 0. Okay, so now I just have 2y on this side. And on the other side, I have this 8 minus 3x. I can't combine those. They're not like terms. Okay, maybe I would say I simplified. The next thing I'm going to need to do is I need to undo this multiplication that's happening here with this y. I just want y by itself. So in order to undo multiplication, remember what do? I have to divide. And whatever I do to one side, I have to do to the other side. Okay, so what's left on the left side, well, let's talk about what this property is. This would have been the multiplicative inverse property, right? I'm multiplying by a half is the same thing as dividing by 2. So we'll call that multiplicative inverse. All right, let's see what's left now. We have just y here, which is great. That equals, we have this 8 minus 3x over 2. Okay, so we're good on the left side. We have the y. Now we need to kind of rearrange the right-hand side to make this thing look better. Again, maybe I'll just say that was simplifying. Okay, we've talked about this before. We've talked about how we can go ahead and take something that looks like this, one fraction. This is the difference. We can write this as the difference of two fractions. Okay, and in the process we can also simplify. So on the right I still have this y equals, and on this side I can say 8 over 2 minus 3x over 2. Okay, and then I can also say, and that's just let's see, we could just call that simplifying also. Now 8 divided by 2 is 4, so y equals 4 minus 3x over 2. And let's do one more step here to get this into the right form. So y equals, using the commutative property, I can move this and say negative 3 over 2x plus 4. Okay, that was a positive 4 there. All I did was change those around. I commuted them, I moved them. Commutative property, if you want to say it's of addition, that's fine. Commutative property of addition. And now, look at what I have. We have gotten this thing all the way down into y equals mx plus b form. So it's easy now. I can look at this and I can tell exactly what the slope is, right? The slope is going to be that negative 3 over 2. I could say m equals or slope equals. And the y-intercept is going to be at the value 4. Okay, so now I know a lot more about this than I did way up here when I started. Okay, you wouldn't have been able to tell me that the slope was negative 3 over 2 or that the y-intercept was 4. But by manipulating it and getting it down into this form from here, Now all of a sudden we can easily see the slope and the y-intercept. All right, so it's time to check your understanding. Okay, so what is the slope and the y-intercept of the following function? We have this minus 4x minus 3y equals 12. Okay, so what you're going to want to do is you don't need to do a statement and reason proof, but you certainly need to take this and manipulate it until you get it to be in the form of y equals mx plus b. So then you can tell me what the m is and what the b is, the slope and the y-intercept. All right, work with this. It's okay if you struggle a little bit. Just keep playing with it until you get it into that form. If you need to, look at the previous example, and that should help you out. All right, we'll be going over this again next class. See you then.